Okay, so example 3, last little bit of our rhombi and square notes. It says quadrilateral ABCD has vertices at A, -1, 0. Okay, so here's A. B is at 3, 3. Here's B. C is at 6, -1. And D is at 2, -4. Okay, so all we know about this is it's a quadrilateral. I'm going to determine if it is a square. Okay, so we're trying to prove, is it a square? So remember, squares have congruent sides and congruent angles, right? So I need to prove, are there 4 right angles? And how I can do that is by using slopes, right? So my first step is prove lines are, I'm going to put parallel for opposite sides and perpendicular for consecutive sides. Okay, so I want to know the slopes. So if I do the slope of AB and the slope of DC, those are 2 opposite sides. Those should be parallel. Okay, so if I do my rise over run from A to B, I go up 1, 2, 3, to the right 1, 2, 3, 4. So AB has a slope of 3 over 4. And DC, if I go up 1, 2, 3, right 1, 2, 3, 4. So 3 over 4. So these 2 sides are parallel, right? Those 2 opposite sides, so that's good. Now if I do the same thing for side AD and then side BC, okay, not only should these be the same slopes, but they should also be opposite reciprocals of 3 over 4, right? That means that consecutive sides would be perpendicular to form those 4 right angles. So I should be looking for a slope of -4 over 3. So if I go from A to D, I go down 1, 2, 3, 4. So there's -4. To the right, 1, 2, 3. So -4 over 3, okay, meaning I have right angles right here and right here, right? Because this was a slope of 3 over 4, this was a slope of 3 over 4, this was -4 thirds. BC, I go down 1, 2, 3, 4, to the right 1, 2, 3. So that is parallel to AD, and it's an opposite reciprocal to 3/4, making it perpendicular over here and over here. So we have our 4 right angles. We for sure know that this is a rectangle at least, right? But I also know that squares have congruent sides. So I'm going to prove all sides congruent. Okay, formally we should be using our distance formula, right? That's what we should do. Okay, and I'll show you. By using the distance formula, okay, every single time, I am going to get the square root of 25, or 5 for each side, right? By me plugging in all the coordinate points and doing my distance formula 4 times, okay? But I'm going to show you a shortcut right here. That way you're not doing distance formula 4 times and maybe kind of eliminating some room for error here. Remember, on a graph, distance formula is the same thing as Pythagorean theorem. Okay, so if I wanted to find the distance of AB, I can form a right triangle from point A to point B by connecting those 2 points with a vertical line and a horizontal line. Okay? Remember, distance of a vertical and horizontal line on a graph, I just count 1, 2, 3, 1, 2, 3, 4. Okay? So I would do Pythagorean theorem with 3 squared plus 4 squared is equal to c squared, right? That's going to get me this distance right here. But watch this, okay? So now let's do the next side, AD, because they should all be the same, right? Not just opposite. So if I connect A to D with a vertical and horizontal line, and I count these distances, 1, 2, 3, 4. Remember, distance on a graph is always positive. We're not talking about -4 right here. This is a distance of 4. And then 1, 2, 3. So if I wanted to figure out the distance of AD, well, then I would do 4 squared plus 3 squared, which is ultimately the same thing as 3 squared plus 4 squared, right? I can add 4 plus 3 or 3 plus 4 and get the same thing. So just by knowing those two right triangles have the same leg measurements, it's going to make these two sides congruent because c squared is going to equal the same thing. Okay, if I connect D to C with a right triangle, right, horizontal vertical line, this horizontal line has a distance of 1, 2, 3, 4. This is 1, 2, 3. So again, 4 squared plus 3 squared or 3 squared plus 4 squared. I'm going to get the same distance. Okay, and then if I connect C to B, I have a distance of 1, 2, 3, 4. 1, 2, 3. So there it is again, 3 squared plus 4 squared or 4 squared plus 3 squared. I get the same distance. Okay, so that is one shorter way that you can prove that sides are congruent, all right? Whenever I'm creating these right triangles, okay, so yes, it is a square. All sides are congruent and all 4 angles are right. So another thing to think about is, sure, I should have used my distance formula, right, which is ultimately Pythagorean theorem. Okay, but on a graph, this is the nice thing about having a graph, is on a graph, when you're forming your right triangles for Pythagorean theorem, we did the same thing as rise over run, right? Over here, I was going up 3, right 4, or down 4, right 3. Knowing that your slopes all have 4 and 3, okay, whether they're positive or negative or 3 over 4 or 4 over 3, that's going to tell you, yes, parallel perpendicular lines. But just knowing that they all have a 4 and a 3, it doesn't matter the direction. It doesn't matter the sign, because distance is always positive, and if I have 4 and 3 on every rise over run, that tells me the distances of the sides of those right triangles, which means all the hypotenuse, which are our square sides, would be the same. Okay, so your slope formula, right, knowing your slopes can also tell you your distances.